Good morning. I am impressed. Look at all these people that we have here for an 8:30 a.m. session on dial plans and routing. It's awesome. Sweet. This is the dedicated group right here. This is the hardcore group, right? I didn't say you were awake. You were here, and that's an accomplishment, right? Especially because you need to take a taxi just to get to this end of the convention center. Welcome this morning. My name is Brian Nice. I am joined up here by my colleague Jeff Clark. We are going to take you through the Lync Server 2013 dial plan and voice routing deep dive. This particular session is not for the faint of heart because we really want to kind of dig into understanding how the dial plan aspects work in Lync and how the voice routing aspects work in Lync. So we're going to start by, I'll go through the objectives here and realize that we're going to start by looking at how we handle the user's dialing habits, right? So we're going to basically start from the end user side of the house and understand what the users are doing and how we need to be able to accommodate those user dialing habits inside of Lync. Then we need to figure out, okay, now that we know what number the user wants to call, how do we get there? Right, what gateway are we going to use? Do we have multiple gateways to pick from? Am I going to go through a SIP trunk that's to IntelliPeer, for example? Am I going to go through an audio codes gateway? Am I going to talk to a call manager? What am I going to do? How am I going to route this call out of the Lync environment? So we'll look at those two pieces of the puzzle and then join that all together and talk about how we would recommend deploying dial plans and voice routing configurations. We then will finish up the second half of the session by going through some very pointed scenarios with regards to voice routing in Lync. Right, so we'll get the basics under our belt first, then we'll get a chance to look at how some scenarios inside of Lync could affect our call routing decisions. Things like call admission control, for example. How does that come into play? Right, so first half, we're going to kind of cover all the core components. Second half, we're going to apply some additional scenarios that would impact the routing aspects that we're about to talk about. It can definitely be a complex and complicated type of deployment. Voice routing is indeed an environment that you can get down into the weeds on, right? But the key component is making sure that we understand what the customer's requirements are so that we can architect Lync properly around it. There are some important improvements that we added into the February 2013 cumulative update, which we'll talk about when we get towards the end of the deck. Before I dive into this, let me give you a quick overview of myself. Again, my name is Brian Nice. I'm a UC voice architect in the Microsoft Consulting Services Voice Center of Excellence. Yeah, they don't give me business cards because it just doesn't fit. I've been doing architect work for about over 15 years now. In a previous life, I worked for a partner, did a lot of integration work with Cisco, did a lot of route switch security and voice work on the Cisco side, and I've brought a lot of that voice expertise into the Lync world. I'll let Jeff introduce himself.
Sure. My name is Jeff Clark. I am as well a UC voice architect. I actually come from a little different background than Brian does. I spent the past 5 years in our premier organization as an escalation engineer. So I'm sure I probably talked to a lot of you over the years, fixing and resolving issues. Prior to that, I worked for a bunch of different telcos on their data and voice switch side. So that's where I hail from.
Sweet. All right, so let's dive in. Start with Lync voice routing, and probably one of my favoriteest slides ever, if you've ever seen me present anything related to voice, is this one. Right, and I like this slide for a number of reasons. First, again, as if you've seen me in other sessions, you know I don't get out much. So these kinds of things are fun to me. When we deliver the Masters training, and I deliver a lot of the sessions at Masters, we'll spend probably close to an hour to an hour and a half just on this one slide. I'm not going to do that to you. Okay, we'll spend about 55 minutes on it. No, I'm just kidding. No, so this is a really important slide, and it looks like the black didn't come out quite as well as we had hoped, so I'll fill in the blanks for you here. Really, what we're looking at with this voice routing slide is this is the all-encompassing soup to nuts process that you would follow from the time the user enters digits into the Lync client to the time that it reaches its destination, whether that destination would happen to be another Lync endpoint or whether that destination would be a phone somewhere out on the PSTN or somebody's third-party PBX. Now, the way that we start looking through this, it's tough to see in the black, but there is, and I'll point it out here on both sides in a sec, there's a line that runs right through the middle here, right? Right where that reverse number lookup is, there's a black line. Above it, all the stuff that you see above it focuses on user dialing habits, right, or user dialing behaviors. Now, the important thing to realize about user dialing habits is just that. They are habits, right? We are creatures of habit. We are used to doing things a certain way. And when a new piece of technology comes along, although it may have new ways of doing things, we're still stuck in our old rut of, I want to do it the way that I'm used to doing it. Right? Classic example. I pick up my phone. Oh, I need to dial 9 to get an outside line, right? Okay, so I dial 9, and then I start dialing the number, right? That's an ingrained user habit, right? Well, you give them the Lync client, and you go, you don't need to do that anymore. You can just click the user. And they go, yeah, I know. 9, right? Because that's what they do. So we have to be able to accommodate that kind of dialing habit. And that's cool. We can do that with the components that are shown here at the top of the slide. Now, I'll take you through a quick run of this. If you look at the top right, user initiates call, right? That's where we're first starting. The user's got their Lync client open, and they want to call somebody. And they just start entering some digits, right? First thing that we need to figure out, what are they entering? If they enter a SIP URI, or they right-click a Lync user and they just do a Lync call, that's really easy, right? There's a black line that you can sort of see here that goes from user initiates call straight down to inbound routing, straight to UC endpoint. That's the simplest of simple. One Lync user calling another Lync user, right? We call that a PC to PC call or an audio call. We don't need to spend time on that, right? Because that's click, done. Right? If that's not working, you probably shouldn't be here. What can I say? The next thing is we start entering some digits, right? Well, now we need to figure out what these digits are that they're entering. Did they enter emergency call digits? Did someone enter 911 or 112 or whatever locale that you're in? If it's an emergency call, we have to treat that special, right? We have to short circuit some processes because, hey, this is an emergency. Get that call out, right? If it's not an emergency call, we need to figure out if that's a globally unique number. What is a globally unique number? Well, our definition of a globally unique number is E.164, right? An E.164 formatted number is, by definition, globally unique, right? How can you tell it's an E164 number? Starts with a plus, right? The format is plus, country code, then the rest of the number, right? So for North America, that's going to be +1, because 1 is the North America country code. And then we have in the North American dialing plan the NPA and NXX values, right? Your area code and exchange and so forth. So we need to figure out if it's global. If the user didn't enter an E164 number, which most users won't type plus and something, right? We need to now figure out what to do with it. That's where the dial plans and the normalizations and all that good stuff come into play. Because now we've got to get this call or this number that they've entered to become globally unique. That's where the dial plans are going to come in. And we'll dig into that in this next section that's coming up. Now, you'll see there's this little section in the middle called reverse number lookup. It is possible that the numbers that the user entered are actually another person's extension inside of your own org, right? Another user dialing habit. We use 4-digit extensions in my company. I'm used to calling Bob at extension 4568. I don't care that I see Bob and Lync and I can right-click Bob and say, call it to 4568. That's Bob, right? That's how I want to call Bob. Well, okay, we can handle that. Type in 4568, we normalize it. Reverse number lookup goes, oh, that number, that's Bob. Behind the scenes, reverse number lookup actually turns it into a SIP call. That's the black line you see there. Hands it to inbound routing, and it becomes a SIP call. Shh, right? We'll get you, click and Lync later, but you want to enter 4568 to call Bob. Fantastic. Call Bob. Right? That's the idea. That's where we're going to focus first. The second half of this is all about routing. Right? Anything underneath reverse number lookup basically means, hey, the number that you dialed, I checked, it's not one of us. Right? It's not a Lync user. So what do we do with it? That's where the second piece comes in. Do we send it to a gateway? Are they permitted to make this call? Right? Class of service, class of restriction. That's the second half that we're going to dig into. So let's start with the first half. We'll talk about normalization. When we start talking about number normalization, that E164 term comes into play. This is our standard recommendation, right? This is not hardcore enforced in the product, right? But this is your best practice. The goal of your dial plans should be, without even thinking through some corner case scenarios, your default scenario should be, my dial plan results in E164 numbers. Period, end of story. Right, so if your users are used to dialing a 9 for an outside line, your normalization rules should strip that. If they're dialing a 011 to make an international call from North America, you should strip that in your dial plans. The end result of your dial plans is E164. Period. There will always be exceptions if you're doing like funky dial plans between like other PBXs and whatnot, but for core dialing scenarios, it's E164. Right? That's what we want. There's reasons for that we'll explain a little later in the day. Right? As I mentioned, once we get that to E164, we're going to see if that number is assigned to anybody in Lync. It could be assigned as their line URI for a user. It could be a contact object. Right? Maybe it's assigned to an auto attendant. Maybe it's assigned to a common area phone. Right? We've got to see if that's assigned to anything in Lync. And if it isn't, well, then we kick it over to outbound routing. We say, go, you take this. You need to figure out where this needs to go. And outbound routing will then be able to select, oh, that's a call going to the London office, right, or to a flower shop or something in the London area. That needs to go to a gateway that's over in London, or it needs to go to this SIP trunk to get out to the public switch telephone network. The key then there is, once you're ready to egress it out to the world, this is where you can perform whatever other additional manipulations are necessary to get out to the downstream device, right? So if I'm leaving the Lync environment and I'm handing it off to a gateway that's in London, right? I might be calling a +44 number. Well, it's already in London. It doesn't need to see the +44, right? So when I send it out my gateway, I could say, yep, you don't need the +44. It's a local call. Out the gateway it goes. I'll show you how to do that as we get on in the deck here. We like E164. If you haven't picked up on that yet, try some more coffee, right? Because E164 is what uniquely identifies a user from a global perspective, right? That's the goal that we're looking for. This allows us to put these global numbers into Active Directory. This allows us to get the click-to-dial functionality working in a predictable manner, right? Because now E164 numbers that are formatted properly in Active Directory get pulled into the Lync address book, which show up in your Lync contacts. Now you right-click, their work number shows up beautifully formatted as E164, and not only can you call them, but organizations that you federate with would, if you allow them for, from a privacy perspective, they would see the numbers, they'd be able to click and call, and life is just fantastic, right? So the flexibility here is immense by allowing us to do E164 because it opens up options for us. If I choose not to do E164, I put myself into a box, right? If I say, you know what, the user dials a 9, I'm going to keep that 9 in the number that they dialed, for the life of the... Well, then I have to make sure that I handle that properly when I get to the gateway, and are you expecting me to send a 9 or not? And it's too many things can go sideways on us. If we can standardize on E164, it gives us the most options available when we want to interconnect out to, say, a third-party PBX, a SIP trunk, a gateway, what have you. Dial plans. Dial plans are the heart of normalization for us, right? The textbook definition of a dial plan, when I teach master's rotations, is a dial plan's purpose is to codify a user's dialing habits, right? We basically have to educate Lync what the user's dialing habits will be. I dial a 9 to get an outside line. I dial 011 to reach, international numbers. When I'm in the Seattle area and I dial 7 digits, you prefix it with +1425, whatever. Those are the dialing habits that I need to account for. The end result of this should be E164. Now, when you build these dial plans, they can be assigned at the site level, the pool level, or the user level, or globally, of course. Globally applies to everything. Site, we mean a Lync topology site in this fashion, a Lync central site, a Lync branch site. The pool level, the pool that the user's account is homed on, or at the individual user level. It is important to realize, although you can have dial plans at all these different levels, only one dial plan will ever apply to a user. And it's always the closest one to the object, which means that user dial plans would trump pool dial plans, which would trump site, which would trump global, right? We don't combine anything. This is not like group policy where we take a couple out of this policy and a couple out of here. No, you get one. right? If there's nothing defined at all, you get the normalization rules that are in the global dial plan. If there's a pool dial plan defined and you're homed on that pool, you get that one and you ignore whatever's in global. If there's a user level one and it's assigned to your user account, you get that dial plan and nothing else. Okay? There's no mishmashing of normalization rules here. Now you can see an example there at the bottom. This is some normalization rules that we've put in. We use regular expressions to do this. Now we do give you a basic regular expression builder inside of the Lync control panel, but it's not a bad idea to actually go out and learn a little bit about regex, because the regular expression builder, it does some pretty basic things, right? But once you kind of learn the syntax of regex, you can get a little bit more fancy, if you will, right? A little bit more optimized as to how you write your regular expressions. Here you can see it's basically built on two things. What pattern are we going to match, and what's the translation going to look like? So this very first rule here says I'm doing 4-digit dial. The 4-digit extensions start with 23, followed by 2 digits. So 23XX, effectively. And I'm going to prefix that with +44207,930, and then the $1 is basically that entire variable that's in parentheses here. So this would end up being a number of +44207,93023XX. Simple, right? Especially at 8:30 in the morning if you haven't had your coffee yet. Nothing to it. This is one of those moments where you just kind of press the I believe button, and then we move on. So we use that button a lot in masters, too. So our dial plans are all about getting to E164. So let's talk about the normalization process. If I start in the upper left... No, I'm kidding. I'm not going to go through this. This is just a slide purely for shock value. It's just to show that there's a lot of stuff going on at the normalization process level. What you need to be most concerned about is, number one, documenting what are your users' dialing habits. What do they do? 4-digit dial, 3-digit dial, 10-digit, 7-digit, steering digits, whatever that dialing habit is, figure that out and codify it to become E164. Right? That should be your first goal. Yes, there will always be exceptions to the rule, but you should not deviate from that unless there's a good reason to. Right? The general consensus for me when I build things is keep it as simple as possible unless you can come up with a business justification as to why you wouldn't do it that way. Right? So start with E164 unless you can figure out otherwise. Don't start with, well, the PBX guys said I should just do 5-digit dial all the way through. Yeah, that's why they're PBX guys. We're Lync guys. We don't do that, right? We want to do it as E164. If they have a really good reason to do it, let's talk about it. But don't assume, oh, they did it that way, let's do it the same way in Lync. No, let's do it the way that Lync is expecting it. This is getting us to E164, okay? There's this wonderful little nuance that you'll see in dial plans called external access prefix. To me, this is probably one of the most annoying settings that we have in dial plans in Lync. Because the concept here is you think, oh, an external access prefix, that's hit 9, right, to get an outside line. So, of course, if I went into Lync, I would see this on a dial plan. Ooh, external access prefix. All I have to do is put a 9 in there, and that takes care of anybody dialing a 9. No, it doesn't. Putting a 9 in that little external access prefix box does nothing. Right? It doesn't do anything because you have to use it in combination with this little checkbox that we have here called internal extension. Let me show you what I mean here. I'm going to switch over to my lab environment for a second. Show you what I'm talking about here. So if I look inside of a dial plan, I'll blow this up in a second when I get to one of the rules. So I'm building this dial plan normalization rule. And in this case, I'm saying it's going to be 2 digits. I want it to prepend this. There's this little checkbox down here that says internal extension, right? The purpose of the external access prefix is to be able to say, look, if the user dials a 9, we're assuming that they're trying to reach an outside line. So any normalization rule that has this checkbox checked, skip it. Because if this is checked, that means that's a normalization rule for an internal extension like a 4-digit dial or what have you. The user would never dial a 9 to get to that because 9 infers that there's an outside line needed. It's an external number. This is just meant to optimize dialing habits. Now, why do we need to optimize dialing habits? There's one specific use case for this, right? And that specific use case is when you're using desk phones, right? Because you know with desk phones, you can either pick up the handset and get dial tone and start dialing, or you can go speakerphone, right? Well, when you go off hook with speakerphone versus picking up the handset, there's interdigit timeouts that come into play. This is meant to optimize selecting the correct normalization rule in the event that someone were to dial a 9. To be quite honest, I look at this from a production deployment perspective. I can probably count on one hand how many times I've actually used this particular feature, right? And the main reason being, I can accommodate the same thing just by doing multiple normalization rules and making sure that I put a 9 in my normalization rules. It's not really something that you want to actively pursue. There's a specific use case for it. In most cases, you're not going to encounter it, right? Wanted to put it in the slide deck so you're aware of it, so that you also are aware that you probably want to steer yourself away from it when you're building these normalization rules in your dial plans. So we're back here to my fun little slide. What we're basically doing at this point, we're focusing on the user, right? And the stuff that I've got highlighted in blue here, like we talked about, we need to know first if it's an emergency call. If it's not, it needs to be global. If it's not, then we need to hit the dial plans. Now, of course, out of the box, our dial plans don't really have a whole lot in them. So, if you just leave Lync as is, you end up over in no man's land here, 404 land, no matching rule, right? That'll happen if you haven't configured or properly configured your dial plans, configured your normalization rules. So users type in a 3-digit, and it doesn't do anything. In the Lync client, it just shows those 3 digits, and they hit call, and the call fails, right? You look in the logs, you'll actually see 404, no matching pattern found, right? We need to match it to something in the normalization rules. Whether it's just a blanket rule that says send it on as is, which would be a bad idea, or a normalization rule that turns it into E164, that's a good idea. That's what we want to be able to do. Because then we can start passing it off and seeing, is it one of us, right? And by one of us, reverse number lookup could make it one of us as far as a Lync user, an analog device, an application, a vacant number range, a call park orbit, right? Those are all things that Lync owns, right? So we can make sure that that call stays within the Lync environment. Voice routing comes into play when the number that the user has dialed isn't owned by us. Now it's somebody outside of the Lync environment. Little terminology note for you. In the Lync world, anything that is outside of Lync is called a PSTN call. Okay? Even if I'm a Lync user calling a Cisco handset, that's a PSTN call to us. Okay? Y'all know that that's not the PSTN, but for terminology's sake, when you look in Lync documentation, anything that's outside of the Lync environment, we treat that like a PSTN call. Now, whether it actually makes it to the PSTN or not, irrelevant to us. It just means it's outside of the Lync environment. So it's passed through a trunk, it's gone through a gateway, it's gone through whatever, but it's gone from Lync. The voice routing pieces are focused around your infrastructure, right? All the bits and bytes we talked about up to this point were really focused around the user. The voice routing stuff is now focused around your infrastructure. Where are my gateways? Where are my ingress-egress points? Do I have gateways in all of my sites? Do I have centralized SIP trunks? How do I get out of the Lync environment from a telephony perspective, right? And that's the second piece that we're going to dig into here, is looking at the infrastructure side of the house. Looking at things like policies, usages, and routes. Understanding the interconnect between these components. Looking at mediation servers, trunks, right? In Lync 2013 now we have a concept of trunk configuration, which we didn't have in 2010 to the same degree, right? We had base trunk configuration, but now in Lync 2013 we actually define trunks in the topology, right? So what does that do for us? How does that help us out? What can we then do when we get that information headed out to this gateway or this IPPBX or this trunk, right? You may need to manipulate the digits in a certain fashion, right? Very common scenario. I'm going to be making a call out. Maybe the call is going out to a Seattle gateway, and that Seattle gateway is not expecting to see a full E164 number. It's expecting to see, because it's Seattle, maybe it's only expecting to see a 10-digit. So it doesn't want to see the +1. No problem. I can manipulate that on the trunk in Lync. So I can say, oh yeah, when you go out that gateway, strip off the +1, give this to the gateway, and now the gateway knows exactly what to do with it. Right? So we'll get into trunk configs coming up here in a little bit. But now we're getting into the infrastructure side of the house. The big picture, if you come out of the telephony world, you will hear terms like class of service and class of restriction. Okay, basically what that means is, what numbers am I allowed to call? Right? Am I allowed to make international calls? Am I allowed to call premium numbers? Am I only allowed to call local numbers or national numbers? Right? That's the concept of class of service, class of restriction. We achieve that by utilizing a combination of policies, usages, and routes. But wait, that's not all we do, right? The set of steak knives are coming later. We also use voice policies to ensure what feature sets are available to the user. Are they allowed to do call forwarding? Are they allowed to do simultaneous ring? Things along those lines, right? That all falls into the policy realm as well, right? So all of these pieces are glued together, and we're going to dig into each of these as we go. But at a very high level, on the left, we've got our voice policies, right? That's kind of the cornerstone for us, because the policies are assigned to provide user authorization, to provide class of service, to provide feature sets. Yes, you can call forward. No, you can't sim ring, right? The usages and routes, they're actually working together to figure out, what are you trying to call, right? What's your worldview, right? I'm in the US, so I have a different worldview than somebody that would be in Germany or in Austria or what have you, right? My worldview is centered around the North American numbering plan, right? So I know from definition, anything that starts with +1 is a national call for me. Right? If I happen to be based in Redmond, anything that starts with, and I'll overly simplify it, +1425 would be a local call. And anything that starts with plus, but not +1, that's basically not my country. That's got to be an international call. That's my worldview. Right? Well, we need to educate Lync about that worldview to say, hey, Brian, based on his worldview, is allowed to call local numbers. He's allowed to call national numbers. We don't trust him calling international numbers. Sorry. He's not allowed to call international numbers. He just racks up too big of a phone bill. Sorry. So we want to build policies and usages and routes to allow that and to disallow the calls that he's not allowed to make. That's what we're going to do in the next couple slides when we talk about usages and routes. Right? Routes are the simple things. Routes are just patterns that we need to match and gateways that we need to go out. Right? The real secret is, can I as a user see that route? Because if I can't see it, I don't know what gateway it is, I don't know how to get there. Right? If I can't see the route, I can't connect to the gateway, I can't make the call. Right? How do we make it so they can see the route? We put the route in a usage, we put the usage in a policy. We assign the policy to the user. Right? That's the flow that we're going to go through here. As you can see, when I build this out, right, I've added another green bubble here, added another route. That route can be contained, you can see the way these lines are drawn. Usages can contain one or more routes. The usages themselves can go into one or more policies. So it's a really flexible method. And the cool thing about this is you can update this as you need to. Oh, hey, you know what? We do trust Brian now. We want to let him dial international. Well, maybe I already have a usage defined for international. All I need to do is put that usage in Brian's voice policy, and voila, he can now start calling international numbers. Right? This is the framework that we're trying to build in the Lync world for routing and authorization. So policies. We assign policies at the user level, site level, global. Same discussion that I had before. You get one of these policies. We don't combine them, right? And it's closest one wins. So if it's assigned to the user directly, that's the policy that you get. If there's nothing directly assigned to your user, then we'll take your site policy. Again, that's a Lync site policy, a central site or a branch site. If there's nothing defined there, then we'll take global, right? But you only ever get one. No combination of anything there. This is a screen cap of the features that we can control. Remember, voice policies are not only about class of service, class of restriction, they're also about what features are you allowed to do in the Lync client. Right? So yeah, I don't want them to be able to do SIMring or PSTN reroute or team call or what have you. The usages are what help us control class of service. Now, it helps us control class of service not only for people like me that may not be able to be trusted, right, for dialing international numbers, but it's also useful for common area devices, for example. Right? I don't want somebody walking up to my lobby phone, plopping down, picking up the phone, and dialing an international number and sitting there for an hour. chatting away. Yeah, I'm good. I don't want that, right? I want that common area phone to be a functional device, but I want it restricted. Yeah, you can call emergency numbers, and you can call our internal extensions, and maybe if I'm feeling kind of nice that day, you could call local numbers. But that's it, right? We can build voice policies, usages, routes, and assign that to common area devices as well, so we can lock down what those devices are capable of doing. Because we don't want to have a device sitting out in your lobby or in the kitchen or whatever that people can use to dial anything and effectively circumvent the class of service, class of restriction that we apply to them directly. Call forwarding SIM ring. This is a new feature that we've provided in Lync 2013. Previously, in Lync 2010, the way that it worked was if I was permitted to make an international call, I would also be permitted to simul-ring or call forward to that international number, right? And there's a large contingent of clients that are like, whoa, wait a second. I don't mind if the dude actually makes an international call, but I don't want him setting SIM ring to an international number so that every stinking call that comes in gets forwarded off to an international number. No, dude, I don't want that. That's not good. Well, in 2010, we were like, meh. In 2013, we have an option for you now, right? And that option is you have the ability of building additional usages and routes that apply specifically for call forward and SIM ring scenarios, right? So the drop-down box that you see here, route using the call PSTN usages. That's the default Lync 2010 behavior, right? If you're allowed to make an international call, you're allowed to SIM ring an international number. Maybe not such a good idea. 2 new options. Route to internal Lync users only. I'll let you SIM ring or call forward, but only to another Lync user. That's pretty restrictive, right? Or the bottom one, use custom PSTN usages. I'll let you build another set of PSTN usages that say, okay, you as a user get usages that let you do internal, local, national, international, premium, toll-free. Sweet. But for call forwarding SIM ring, you get internal, local, national. That's it. So as a user, I could still make the international call, but now I can't SIM ring or call forward to an international number. I can only SIM ring or call forward to a national number. All right, the usages. The usage itself is effectively useless because it doesn't really do anything, right? The usage is just a name. The usage's job is to be the glue between the user's voice policy and the route, right? Because the route is what does the work, right? The route is the match, the pattern match, the number that we're matching, and the gateway that we need to talk to or the trunk that we need to talk to. That's the goal. That's where we need to go to get out of the Lync environment. The policy is what's assigned to the user. How do we get the users to see the policies? Usages. Usages are the glue between the policy that's assigned to the user and the route that's attached to the gateway. So usages are nothing more than names. And you should come up with decent names, right? Usage 1, usage 2, usage 3 is probably not a good way to go. Okay? Unless it's your last day, then man. We typically do usages like local, national, international, premium, things along those lines. Now, you want to come up with names that are more globally friendly, right? You've seen in some of my screenshots, I've done things like UK national, UK international, right? I might do US Seattle local, US Seattle national, or US national, US international, right? You want to come up with a naming convention that can work globally. Because if you just call it local, local to what, right? A local call to me in Southern California is not the same as a local call to Jeff in upstate New York, right? Not even close. So I would want to name them, the usages appropriately. So I know this is a New York local number. This is a Southern California local number, or an LA local number, or what have you, right? So good naming convention is always key. The routes themselves are the key components to get us associated to a gateway or a trunk. The routes get selected based on a matching pattern, and as you could guess, the matching patterns, as you see in the slide here, are E164. Yet another reason why we tell you to normalize everything to E164, because then it makes your route matches simple, because it's all based on E164. Think about it for a second. We give usages, and I'll use the center of the world from Microsoft's perspective, right, Seattle, as the example. A Seattle local call starts with port 25. So I can easily build a route in my head, Seattle local, plus 1425. Seattle national, plus 1. Seattle international, plus, but not plus 1. Done. I just built my routes like that. Because it's E164, I didn't have to think, oh, well, if they dialed a 9, then it would be the 9, but what if the 9 was 911? But what if it I don't have to think about that because it's already globally unique by the time it gets to me from a route perspective, right? So we want this to be E164. The usage will control if the user is allowed to use the route. If the usage isn't in the user's voice policy, they can't see the route, they can't get to the trunk or the gateway. Sorry, you can't make the call. We can control preferences of gateways. You can have multiple trunks in the same route. That basically is just we'll pick whichever one we want randomly, right? That's great if you had multiple gateways like in the same site. I had 2 gateways in the Seattle site, and I could care less which one you go out. Then go ahead and put both of those gateways in the same route, and life is good. If you're trying to manipulate and say, I want calls to always go out gateway A first, but then use gateway B only if gateway A is not working, don't put them in the same route. Okay? There is no discernment when there are multiple trunks or gateways in the same route. We will just indiscriminately say, yep, there's 2 of them, A. Hey, you know what, let's do B this time. It's just totally randomized. Same thing with multiple routes in the same usage, right? If you put multiple routes in the same usage, of course, we first have to make sure that we match the pattern. But if there are multiple routes with multiple matches, we'll just pick one. So again, if you're trying to get very granular and say, well, I want it to go this gateway primary and only ever use this gateway if the primary is down, you have to have those routes in different usages, right? So I can have a route, maybe my national calls that all start with +1 go out my Seattle gateway by default, but in the event that Seattle's down, they would go out LA as a backup. I would need 2 different usages. One usage for US national via Seattle, one usage for US national via LA. That'll ensure that we always go out Seattle first, and the only time we would decide to go out LA would be if Seattle was down. So let's take a quick example. My usages, some pattern matches, some various gateways associated with them, right? You follow the lines. The red lines are all in internal usage. The blue, local. You've got that greenish one, Seattle National, Seattle International, and my ever-popular last resort usage. So I want to call this number. What is outbound routing going to do when it starts looking at this? Well, it's going to go, +1, 206, 555, 1212. Well, what's going to match this? Let's eliminate the things that don't match. Now we're left with these. These are all the possible routes that match, right, from a pattern perspective. Because they either start with plus, it starts with +1, starts with +1, 206, or 1, 206, 555. Which one are we going to pick? Okay, this is the interactive part. You can say something back to me. Well, it's it. It's it. Yeah, top one. Yeah, number 5, right? Why? Because it's the first one, right? A lot of people look at that and go, oh, well, it's going to pick that because it's the longest match. No, it's going to pick it because it's the first one in the first usage, right? If this +1, 206, 555 was way down here under last resort usage, we wouldn't pick it because it's my last resort usage, right? I didn't get down to that yet. So we're figuring out what patterns match, and now we order them based on the usage. I'm going to hit this guy. Now, of course, if gateway 3 is down, well, now where am I going to go? Well, I got to go all the way down to number 4 here with my last resort usage, right? Because this, none of those routes are going to be available because the gateways are going to be marked down, right? We'll talk about that a little bit later. Another example, 666, 1212, 312. Same idea. We match them out. Now, there's nothing in the internal usage to match this. That's okay. We move on to the next usage. We look in local usage. We found a route. It starts with +1, 312. Now we've got 2 gateways in there. Which one are we going to pick? Whichever one it feels like. It might be gateway 1, might be gateway 2. 2 gateways or trunks in the same route, we're just going to pick one. Right? Again, if your intent is to say, well, I always want it to be gateway 1, well, then you need to have another route with gateway 2 only and put that route into a different usage. right? So that it purposely selects this one and not that one, right? Even if it's two different routes in the same usage, you're not guaranteed. Is there a question? If you want to jump to the mic, would be fantastic. Only took me for 3 days to get that right.
If gateway 1 is down, will it fail over to the second gateway?
Well, if gateway 1 is down, it wouldn't even pick it. It would pick gateway 2. Because we would know, by the time we go to route this call out, we'd know within seconds that gateway 1 was down, and we'd go to gateway 2. Yep. Yeah. Yeah, the question is if you had +1, 3, 1, 2, and +1, I'm smiling at Jeff because we went through this. You would think it would do the longest match. It doesn't. It just picks the first match it finds, which would be +1. So it actually tends to favor the shorter match rather than the longer match. So yet another reason why, if you're going to do that, don't put them in the same usage because it's not predictable the way that you would expect. Anyway. All right, trunks are the last thing I want to talk to, and I'll flip it over to Jeff. Trunks define the relationship and capabilities between mediation servers and gateways. Now, what's new in Lync 2013 is we define trunks in Topology Builder. Right, so you go into Topology Builder, you define a new trunk, and you're basically creating a definition of mediation server and listening port to destination gateway and listening port. Right, that's our combination that we have with our trunks. Those trunks then get represented inside of Lync Control Panel under your trunk configurations, and I can set various settings on them like you see here in this screenshot. I'm not going to talk about every one of them, but the common ones that you would see set are things like, do we support encryption? Is it required? Is it optional? Is it not happening? Right? So obviously, if I'm talking to a UCO-IP qualified gateway, it's one of the enhanced gateways, encryption is good to go. Right? If I'm talking to an IPPBX like Cisco, encryption ain't happening. Right? We can't do TLS and secure RTP with Cisco because we have a cipher mismatch in the secure RTP stream, so we can't do it. Do we do RTCP, real-time control protocol packets? Does the gateway support RTCP or not? Should we turn that on or off? What about refer support? Should that be on or off? Pay close attention to that, right? Especially with the documents we have on the UCO IP site. Look to see whether we tell you to turn refer on or off. Don't just think, I'll just leave it on, it'll be fine. No, it won't be fine, okay? Refer is all about transferring calls, right? Call comes in, I put it on hold, I transfer it to somebody else. If we're expecting the other side to support refer, we're going to try to transfer that call using the refer verb in SIP. And if it's like, what? Then there goes that call transfer. It doesn't happen. We don't want users to find that out for us, right? Let the guys that do the testing at TechVision find that out for you and write it up in the documents. Right? You also have the capability at the trunk level of being able to manipulate the digits. And this kind of brings it all back to the discussion I had before about E.164 and why it's so valuable. Right? Let's look at this example. We've got our friend Alice. Alice calls this number in the UK. 4422123456 Sweet. We normalize that. Let's say she dialed 1234567 and it normalized it to that E164 number. That's great. Now we've configured least cost routing for her to be able to dial that UK number via a gateway that's in the UK. Fantastic. We could send that all the way across to a mediation server to a gateway that's in the UK. Right? We can strip down the numbers that are necessary and hand it off its merry way. But what happens if we can't reach that mediation server on the other side? Maybe the WAN is down. Maybe the mediation server got turned off. Maybe call admission control got in the way. Right? Well, what if we had another route below it that said, well, go ahead and make that call, but this time it could be an international call out of a Seattle gateway. Well, the number that the user dialed never changes. It's just from an outbound routing perspective, we now say, oh, I can't get to that gateway that's over in London. No worries. I've got another route here that says, let's use the gateway that's in Seattle. Well, obviously, when we hand it to the gateway in Seattle, it's not going to know what to do with a +44 number, right? The gateway's like, dude, that's international. How do you dial an international number when you're in the US? 011 followed by the country code and blah, 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 right? No worries. At the trunk level, we'll translate it. I'll strip the plus off. I'll put 011 in front of it, and now I'll give it to the gateway. Because that number was formatted as E.164, I have lots of choices as to where I want that call to go, And then wherever it ends up as a destination gateway, I can translate the number there and format it properly. Right? Now, the first argument people say is, well, I could do that at the gateway level. Sure. You want to log into 25 gateways and configure them all, or do you want to do it centrally in Lync Control Panel? I'd rather do it centrally in Lync Control Panel. Yeah.
So how do you dynamically do that for other calls that are going to that same trunk that don't necessarily need to strip those numbers or prefix them?
Yeah, the question is, how do you handle that for other calls that go to that? And that's part of the dial plan that you're going to lay out, right? You need to figure out calls that come out this gateway. What do the numbers need to be formatted as, right? So if it's a call that's coming out of a London gateway, I know that anything that starts with +44, I can strip off the +44 because it's in country. I know that anything that's not starting with +44, I would need to format as a national or international or whatever call for that particular location. So you have to know that location's dialing rules, right?
There's also the same concept of if I'm using the same gateway for different people or for a backup scenario versus someone's always local, you can build different trunks. So as Brian talked in Topology Builder, instead of always having to create gateways like we did in 2010, now you can create trunks. These trunks map back to the trunk configuration that Brian's showing you right now. So I can theoretically have a trunk specifically for a backup scenario and then a trunk for an always like local scenario. So then we can treat that number differently.
You have to have multiple trunks for the same gateway.
Exactly.
It's possible.
It's
Yeah,
possible.
there could be a scenario for that, right? Basically, what you're doing here with these trunk translation rules is now you're trying to figure out what the worldview is from the gateway's perspective, right? Because the dialing habits and all that was the worldview from the user. Now this is you're trying to figure out what's the worldview from this gateway. And this gateway knows that when it makes a local call, it has to put a 0 in front because it's in the UK, right? And when it makes an international call, it has to do this, has to do that, right? Its worldview has to be accounted for here. All right, I ran a little past, but
No, it's
you
fine.
can make up the time. So I'm going to switch it over to Jeff, and he'll talk about some of the scenarios here for you.
Yeah, so we've got a couple of scenarios we're going to go through here. The first one is going to be CAC and call routing. I know myself and Brian throughout this week, we've had a couple of different sessions where we've introduced CAC. So one of the pieces or one of the abilities of CAC is to be able to reroute a failed call or a bandwidth restricted call across the PSTN. Right, so we're going to go ahead and take a look at that and what does that look like and actually how does that happen. Along with that, there's also some assumptions being made, is that the client actually has bandwidth to these alternate mediation servers, right? And there's ingress and egress path available to these mediation servers. With that, we start looking at least cost routing. Brian talked about least cost routing that allows us to drop that UK number off on a UK gateway or a UK mediation server. That might not always work in a CAC scenario, so we really want to think about that and what implications we have. If your backup route is to go across that WAN, is CAC going to kick in and deny that call? Right. So on a really simple call flow here, so we've got, just to kind of to set this up, and if anyone's not used Snooper from the Lync 2013 tool set, this is a ladder diagram that you can actually build right from Snooper. So if you're ever doing any kind of troubleshooting, and you want to look at the call flows, like if anyone's familiar with Wireshark and you've seen this call flows in Wireshark, we can now do the same thing in Snooper. So if you have a very complex call, you can think of like a response group call, the ladder diagram can really kind of help you picture what's actually happening, right? So in this particular case, the very top left box here is just to say user A, it's Alice in this scenario. And then we have this local is the front end server, and then the third box would be that third user, right? So Alice goes ahead and makes this call. She's trying to call Bob. She happened to actually dial his phone number. The front end server is going to go ahead and route that call to the user. And the one piece with CAC that we kind of talked about earlier this week, that it's always the receiving side's decision to accept that call or to not accept that call. So in the scenario where Bob does not accept that call, Bob's going to send back a 488, not acceptable here, which is telling the end result is to tell the client that I can't take your call, right? So, and then that information actually gets presented back as a 199 to that end user. So what we're going to do is we're going to take a little step in and actually look at what that 488 looks like and what that 199 looks like as well. So in that 488, so Bob sent his 488 back to the front end server. right? So the two important pieces here is the 4088 itself, plus the actual diagnostic code, the actual reason code, saying that there's inefficient bandwidth. So we're going to go ahead and attempt a PSTN reroute, right? So this goes back to where Brian was talking, where we need to have these backup routes. In this particular scenario, it was a peer-to-peer call, right? But now I have an opportunity to actually reroute that call across the PSTN. So I was calling Bob. I'm in Seattle, and I'm calling Bob, who's in New York. I can't reach him over the WAN, but I can actually reroute that call over the PSTN. That's another. You start getting into other scenarios as well with E164, right? So those are other things that become important versus just having 4-digit dialing. When we have everything as E164, we can handle our routes more appropriately. Because there could be scenarios if you just did 4-digit, dial plans, 4-digit routes. There could be scenarios where we can't actually route that number across the PSTN. So when we look at the 199 that gets handed back to Alice, right? So from the front end, again, we're letting that user know that, hey, you tried to call Bob. There's not enough bandwidth to call Bob, and we're going to go ahead and attempt the PSTN reroute. With that PSTN reroute, Alice gets a little pop-up in her client that says the call may take longer, right? So this lets the user know that, hey, we're trying to reroute that call. Just hang on a second, right? And we're going to go ahead and connect your call to Bob. Continuing on that, with the PSTN reroute, here's a log from outbound routing itself. And we have a couple pieces highlighted here. One, when we go to make that call, you can see where we step into this function here where we're checking vacant number range. This is a common piece that we always do on any outbound routing process. But the big piece to know here is that MS skip RNL, right? So as Brian talked before, anytime we send a call to the front end, we're going to go through an RNL process to see, can I match this number to a user's SIP URI? Well, in this particular case, we could, but this little flag at the end basically says, don't do that, right? Because otherwise, we would just fall into the same trap again, right? I go ahead, if I match back to Bob, try to call Bob, he's going to say there's not enough bandwidth, and the calls is going to be in this infinite loop. So we say, don't do that. Okay, great. So we found the parameter, and then we're going ahead and just continue on. Another big piece that we have here is actually where we find the voice policy or the UC policy assigned to Alice in this particular scenario. This component here where we've got listed as tag Atlanta. Tag, anytime you see tag in any logs or just from PowerShell, tag always just means user policy, right? So we know it's a user policy. It's not a site policy or a global policy. Out of the box, when you set up voice policies, the name is always default policy. No matter what you call it, the name field is always default policy. So if you're troubleshooting these problems, you won't see tag Atlanta unrestricted or whatever you called it. Thank you, Brian. Go ahead and switch. So you won't actually see this. What you'll see is just default policy. So it can be very frustrating to troubleshoot which policy did it actually get picked up. I have no idea, right? So you can go in and actually change this, right? So on a given voice policy, or and then we can actually go ahead and actually change the name field to match what the actual identity of that voice policy is. So any kind of troubleshooting scenario, I can go and find it in these outbound routing logs much easier.
Yeah, just something a little bit helpful in the logs, right? All I did in this one was I changed the one for Atlanta. So all the other ones, that's how it is out of the box. So you go ahead and name it all nice and pretty inside of control panel or what have you, and it still calls it default policy. So you just use set CS voice policy to give it an actual name. I happen to match it straight up to the identity name. Now when you look at it in the logs, it won't just simply say default policy. It'll actually show tag Atlanta unrestricted. And now I know that that's actually the Atlanta policy applied.
Right, yeah. So we would get, a lot of times when I worked on the escalation side, we would get customers that would send us logs, and we're trying to find out what policy is being used. It's easier in a scenario where if you're just testing, they don't want to change it for whatever reason, name it just anything so you can actually flag it in your logs themselves. So here, again, we have, so we found the policy going to be used for this. The target phone number, that's the actual PST number that we're trying to call. And then we're going to go ahead and find the usage that's in that policy itself. In this case, it's internal extensions. And we found the route that's available for that particular usage that's in that policy. So then we can go ahead and attempt to route that call. So part 2 of this. So in this particular scenario, we're going to go ahead and kind of just, you can look at it, we're going to kind of continue on. So instead of us making a call to another user, we're actually trying to make a PSTN call, as we kind of talked about. In this case, it's just an extension, but we're leaving the mediation server, right? So the invite from that mediation server, we've already gone through the voice policy. We figured out what route that we actually need to go. So we say, okay, I need to talk to PSTN B1. In this case, this is that particular gateway object that's in that route, and who owns that gateway or who manages that gateway is pool B, right? So we've got a co-located mediation servers running on pool B. We're going to send that invite to that mediation server. That particular mediation server responds back with a 503. So we have 2 retriable errors that we use in CAC and we use in just other gateway selections, the 503 and 504. So in this particular case, we actually get a 503 back that says, we'll actually dig into what it actually says here, but it lets us know or lets the front end server know, the entity making the call, that I cannot go ahead and in progress, you need to look at another available route. So you kind of look at it from a user perspective. We can do that, and also from the front end perspective as well. So again, what we see here, so instead of that 199 going back to the user, in this particular case, we get a 503 because there wasn't enough bandwidth to that mediation server. So again, that's kind of where we talked about least cost routing can really come into play. So it's great for a normal situation, but you really want to think about it from a CAC perspective as well. Is my backup potentially going across the WAN that could be affected by CAC as well here? So again, we dig into the outbound routing log. We get the 503, and then here we find the phone usage available. It's this ATL backup for internal extensions, and then we go out that local gateway. Originally, we were trying to make a call out the Boston gateway that was managed by the Boston mediation servers. There wasn't enough bandwidth available, so we went ahead and followed our backup route, which is out our local gateway. So we're going to take a look at the conference dial-out components here. So one of the things that we really struggled with in 2010, and you can even step it back all the way to probably 2007 R2, was the ability for anonymous and even more than not is the non-enterprise voice-enabled users to be able to dial out when they join a conference. In Lync 2010, I can allow anonymous participants to dial out if the meeting was created by a user that was enterprise voice enabled. We'd follow that particular voice policy to make any dial out when I joined that conference. In 2010, if I was a non-EV enabled user, and I was an authenticated user, I joined that meeting, and I try to dial out to call to my desk phone as a scenario, the call would fail because you would see in the outbound routing logs, this user is not UC enabled, has no voice policy, we're done, right? We would just fail. There was a workaround you could do. You could add a static route to route directly from your front end to your mediation server that says, any route for this domain, go ahead and send the call out. That opened up some issues. One of the issues that I remember seeing the most was if you ever had hosted Exchange UM, then hosted Exchange UM would actually try to follow that route as well. Instead of going to your edge federation path, it would actually try to go to your mediation server, and those would fail. So in 2013, we now have the ability in Control Panel and PowerShell to go ahead and hit this great checkbox that now allows for non-enterprise voice-enabled users to actually dial out. So just remember, in this scenario, if I'm a non-EV user joining a EV user's conference, I'm going to use their voice policy to actually make that outbound call. So here we kind of look at these logs here. So we have the organizer here, Alice. We have the participant here, in this case, Ted. Ted actually wants to make a outbound call to his desk phone. We see this user is a non-EV enabled user, and we do have the organizer's policy allowed to make that outbound call. So then we can actually apply the rules from that organizer's policy to actually allow that call to progress outbound. And it's always going to go from the organizer's phone number, right? So in OCS days, we actually sent that call out of the AV MCU's group, but now we actually map the organizer's tell-URI. So the outbound call always looks like it's coming from the organizer. So an example, if the EV user or the non-EV user is the organizer, so there's a scenario where you have a PC-to-PC enabled user. I'm going to set up a conference. And there could be scenarios where other users join, other non-EV users join that meeting, and they want to be able to dial out. Or the organizer himself wants to be able to dial out. So in this case, Ted, he's a non-EV user. He's also the organizer. And then now we want to actually make an outbound call. So what we find here is that Ted does not have any phone usages, right? He does not have a way. He does not have a voice policy to actually make any outbound calls. So the call would fail. So the solution for this, right? There's two paths here. First solution is you could, for anyone that's enterprise voice enabled, you could be signing a user policy to those particular users. For anyone that's non-EV enabled, you could use a site policy or a global policy. That might not be the best choice, but that is a choice. The other option is actually assign that policy to the user directly via PowerShell.
So I just want to switch over here for a sec and kind of show what we're talking about here. This was, you remember this, right, our voice policies and all that good stuff, right? So this is just showing the voice policies that we have, and then I would use a command like grant CS voice policy to be able to assign this to a user. All right, so I want to take a moment and switch into a quick little demo here before we get into the next section. So that we can see, because we're running a little short on time here, and I want to get to this last demo because this is a pretty interesting piece that we have. This is a lab environment, and what I want to show you here is I have two users. We've been talking about them. Jeff's been talking about them before, right? We've got Alice and Bob. Our Alice and Bob in this world are actually, Amy is my Alice, and she is in the Atlanta site at the moment. And I have an environment set up where, at the moment, I've got multiple sites, including Atlanta, including Boston, and so forth. And right now, I've got two virtual machines. This client virtual machine that I have up has Amy. She's in Atlanta right now, right? I have here, this is a 3CX phone, which is actually connected to an Asterisk PBX, simulating our PBX environment. Could also be simulating our PSTN kind of environment, right? So in typical fashion, I can dial Amy's number from the PBX. Amy gets a call. Life is good, right? Amy can dial back, and everything is great. Well, now Amy gets up and moves. She gets on a plane, and she goes from Atlanta to Boston. Now, you'll notice when I get signed back in here, I have location services turned on. So her location's automatically populated now to be the Center City building, right? Life is good. If she attempts to call 121, look at the phone over here on the right. That's the same phone number as this guy here, right? But it's actually in the Boston site. So she's calling that Boston PBX Life is Good through a PSTN gateway that would be in Boston. But what happens now when I'm back here in Atlanta and I try to dial Amy? It's ringing. It's ringing. I'm not getting any toast. Huh. Oh, it's connected. What happened? It's in voicemail. Why did it go to voicemail? Why didn't I get a there must be something wrong with my lab, right? I don't know what I'm doing. Right? What's wrong? Why didn't I get a toast? Is there some new feature that we have that would prevent us from being able to receive calls or send calls based on the location that we're in? You'd think it's CAC, but it's actually location-based routing. New feature that we added in the February cumulative update is the ability to do location-based routing. Location-based routing is all about regulatory compliance, right? If you're at all familiar with the telephony world, you know that you will get into situations, for example, in India, prime country, right, that you'll get into where the telcos have strict laws that say, no, you can't backhaul these calls over your IP network. You're cutting out the telco. Hey, it's money. You can't do that, right? If you are in the office in India, right, if you're here, you need to be able to send and receive calls from that office, right? If you travel out of Bangalore into New Delhi, right, you're allowed to make outbound calls, but you must use the gateway that's there in your location. And when an inbound call comes in to this other site, sorry, you can't bring that call across the WAN. You have to be in that site. If you're not there, you can't take the call, right? And when you're going out, you have to go out that local gateway. That's it. I mean, regulatory reasons say you must adhere to this, and the legal teams will be all over you for that. Until this feature, we didn't have any way to natively do that inside of Lync, right? Now we do with location-based routing, right? We will route the call based on the physical location of the caller. We will then, as nature would have it, prevent the ability to do any kind of toll bypass or least cost routing, right? Because that would violate the telco's arrangements. You have to have location services enabled for this to work. I'll show you in a second. We've got to have the gateways, got to have the users, and you need to turn it on, right? It's there, but it's not configured or enabled at all in the cumulative update. So its job is to enforce outgoing calls from a gateway that is in the user's location, period. Right? So I'm over in India, I'm in New Delhi, I'm making that call out. Boom. I have to use a gateway in that site. If there is no gateway in that site, I can't make the call. Right? And if my DID is not on that trunk coming in, I can't receive the call. That's the rules. Right? This will prevent incoming calls if you're not in the gateway's location that owns your DID. It'll prevent outgoing calls and incoming calls if you're in an undetermined location. So think about that. If you have users that may want to come in through the edge or something like that, if we can't figure out where you are, you can't make or receive calls, right? Because you would be violating the telco's agreement by doing that, right? Outgoing calls through the international PSTN, if a gateway local to the user's location cannot be found, right? There are options that you can build, but again, a lot of this comes to talking with the legal teams about what do we need to do to meet the letter of the law, right? And we as Microsoft can't dictate what that is. You've got to get with the telcos. They've got to come in. They've got to look at your solution. They've got to certify it as it's deployed in your customer's environment, right? So we can't tell you it has to be this way. We can give you guidance. But you've got to work with the legal teams and the telcos to figure it out, right? So we're going to use Lync's network sites and subnets to configure this. We need to create a new kind of policy called a voice routing policy, right? Earlier in the lecture, we talked about voice policies that are assigned to users. This is a different kind of policy. It's called a voice routing policy, and it doesn't get assigned to a user. It gets assigned to the site, to the network site that we build inside of Lync. Now we build our trunk configurations. We turn on location-based routing at the trunk level. You want to make sure that you only do this for your PSTN routes. Okay, don't set this on trunks that go to like an internal IP PBX or something like that. Bad idea, right? Because we don't want to break being able to call a 4-digit extension on that's the telcos don't care about that, right? It's stuff that goes out to the PSTN that they care about. So make sure this is only set on PSTN trunks that you're doing, right? You need to enable this setting in the user's voice policy, right? So there's a little flag. Remember we talked about voice policies, talk about which features you're allowed to use. Well, this is a feature, right? And then you have to globally turn on location-based routing for this to work. So the next couple screenshots are going to give you the commandlets behind it. I'm not going to go through every little piece of syntax. This is all well documented on TechNet, but we tried to pull it together in this slide deck so you don't have to go hunting all around for where all these pieces are. Right? So this is what it looks like to create the new voice routing policy. That new voice routing policy is going to contain PSTN usages, which you know that the usages are going to be associated with routes. Right? Here's the really cool thing. You might be thinking at this point, oh my gosh, I need to build more routes, and now I've got to think about what location they're in. I don't want to. Cool thing, we actually will use these routes in conjunction with the routes that the users have for their voice policies. What I mean by that is, look at that second bullet point. The user's assigned voice policy is used for authorization. Class of service, class of restriction. Okay, what that means for me when I'm configuring location-based routing, I can be as permissive as I want, right? So my lab, my routes, plus. That's it. It starts with a plus. That's all I need to do. I don't have to be restrictive for the voice routing policy routes because the authorization happens before that. The authorization happens in the user's voice policy. So I don't have to worry about controlling that at the voice routing policy level. And there you see it. There's Amy making her call out, tag Atlanta. Whoop, we want to use the Atlanta. That's all the voice policy that's assigned to her. That's her class of service, class of restriction. All right, you're allowed to go ahead and use that. And we would want you to go out using this route, USATL local extension. Now it flips through and goes, oh, wait a second. At least one route available for target. Call authorized, picking a usage from the site policy. We found that you're in a site that is enabled for location-based routing, which has a voice routing policy assigned to it. This is going to trump what you did up here. So I know you wanted to go out via USATL. Sorry, you're going to go out via Boston because you're in Boston and you're required to go out the Boston gateway. Okay? Now again, in my lab, I'm doing it with US, but it doesn't apply in the US, but you get the concept, right? So this site policy overrides and says, sorry, you're going to use this usage, LBR US Boss, and the route name is US Boss. So the user thought they were going out Atlanta, least cost routing. Sorry, location-based routing says, you're done. You got to go out via Boston. So there's turning it on at the user policy level, prevent PSTN toll bypass true. Turning it on at the site level, right? There we're assigning that voice routing policy that we created and turning on location-based routing. At the trunk, enable location restriction true, and then globally turning that switch. Lots of little nerd knobs that we have to turn to kind of get this thing working, but at the end of the day, this provides us an extremely powerful mechanism for being able to control calls that ingress and egress from particular locations. Now again, this is, because we're talking about this at the policy layer, this is not an all or nothing, right? So you turn this on for your users that are in India or what have you, right? You don't turn this on for your users that are in Salt Lake City or New York or whatever, right? So we can be much more granular about how we enable location-based routing. All right. That wraps up our dial plan and voice routing stuff. If you've got some questions, if you can take a minute to kind of head over to the mics, would be a good idea because they want us to make sure that we get people at the mics to record them. If not, on behalf of Jeff and myself, I want to thank you guys definitely for coming out early for the session and enjoy the rest of your time here. Don't forget to fill out your evals. We got a question.
On the location-based routing, if you're using a third-party LIS, does that affect?
If you're using a third-party LIS, does that affect it? No, it shouldn't. I can't say that I've tested it, but it shouldn't affect it.
Those subnets, right?
Yeah, I mean, it's all still, we'll still be able to query that and determine it. So
separate components, essentially, right, yeah.
In both the external LIS and the Lync LIS?
You have to be able to have sites defined inside of Lync's network topology because that's where we're applying the location-based routing policy.
All right,
to.
so you will have to have them set up in both locations.
Yeah.
Cool, thank you.
It's a different thing. There's a list. Yeah.
Jouw comments uit erom.
Sorry.
One more? Yeah. From can you from CDR, if you have simultaneous ring turned on, can you see that correctly for billing purposes?
Can you see?
Oh, in the CDR data?
Yeah. Yeah.
Oh yeah, yeah. You'll see that in CDR data. Yep.
You'll see all those diagnostic codes and everything.
Yep. Just everything that we saw in those logs there, you'd be able to see inside of the CDR data.
Thanks.